wir große Mengen an Texten schnell sehr präzise klassifizieren und sagen, was der eigentliche Inhalt ist.
Il y a deux tiers qui est utile, le reste c'est dû pour n'importe qui, mais certainement pas. Et avec ce fingerprint là, ça c'est effectivement la technique.
I will talk about, of course, semantic technologies, but I will try to give you a little bit of focus how we can make money with that. And because sometimes when you look at these technologies, it looks like very complicated sometimes, and a lot of manual work behind in order to get all these models done and so on. But I hope I will show you some ways how you can simplify that and how you get less costs and higher efficiency by using all what you know which is existing already, but combine that with some new approaches we have came up with. Well, Decker said computer is a moron. Well, I wouldn't say it's a moron, I would say it's a slave, because he's as good as I am if I'm the programmer. And so, especially if he comes into data intelligence, it really appears to the programmer how he intelligently makes the system up or prepares the questions you can ask in the future and all that. And so we have a lot of challenges and problems there at this place. Means if you have a very clever programmer, of course he will, think about the application you're going to ask for or the questions you're going to ask for this database. When we were a startup, of course we had to pitch for investors and everything, and usually they said, okay, you have your 2 minutes, give you a pitch, your elevator pitch. And I usually said, I don't need 2 minutes, I only need 15 seconds. AI1 will give you an answer to a question you did not know that you have to ask for it. And so what we try to listen to the data so that not me as a programmer decides about what's important, because it's already in there. I mean, take any text, take any A4 sheet of paper with text. This text is written according a certain language and grammar. So therefore, there is an intrinsic semantic. It's there already. So the trick is to get out the minimal semantic, the minimal intrinsic topography out of that page. You take 1,500 pages of any kind of a content. In this case, we took alcoholism. We had it in a project with some hospitals. And we were indexing these documents. We tried to find out the associations, the semantic associations. And we didn't want to use any models, any ontologies at that point. We wanted to find out what is inside the documents, because it should be language independent. So if you take cosine for English, for example, it will work out fine. It will take you about 2 days after you optimize the whole process to index those documents. You read the abstract and you select a handful of words. And then you key that into Google and you go for search. What will happen? Well, in this case, we had about 400,000 hits. It was a popular thematics. And of course, what you do, you read the text, you maybe pick 1 or 2 words out the text, and then you think to be clever, you add on some of your knowledge, some additional words to the text. And then you go and search. But that, in reality, will fuzzy your search, because those words are not even in the content. And maybe the content is not even having a strong relation to these words you put in addition. So what we did with the AI1 approach, the content was fingerprinted, semantically fingerprinted automatically. So the system picked the most important words out of the content and went via Google and searched. And we had only 2 results. And we knew that this is right because there were only 2 publications. Now, the thousands of search results we had with these additional words, when we were crawling all those, and then we were following all the links, we came to the 212. So Google was right, but it had, of course, all the copies of the copies of the links of the links of the links also. So number 1 result was at position 400, and number 2 result was a position, I don't remember, 1,000 and something. So it was right, but it had all the noise. If you have the right words, which really fingerprint the content you're looking for, we had only the 2 results we were looking for. So if we can automate that, that would be a big step forward, because that would solve a lot of work and effort you have to do to get semantic out of a text. And so what we did, the way how we did that, we created a kind of a synthetic brain. It's a kind of a neural environment. It's nothing compared with what you know, because it's not published. And it's not in a derivate of Cohonen or perceptron or anything like that. We call it holosemantic data space. It's a data space which is self-organized, self-learning. You add on text inside, and it will bring back the smallest possible topography of the semantic inherently in this text. Now, that's not enough, of course. It is just the first step. So then, after that, you add on all the processes you have already, ontologies, thesauries, whatever you like. But the trick is, instead of using the ontology to be a model to get semantic out, you get the semantic out generically out the text, and now you compare it with the models and try to fit it in your work processes. And that saves a lot of time, that saves a lot of effort to build up the ontologies. Number 2, it will tell you if the ontology has to be changed, because it will tell you whether new words appear. In Zurich, we crawl every day about 35 news sources. Tagesanzeiger, Neue Zürcher Zeitung, etc., etc. And what we do, we check out whether the ones are really new and which ones are more important than others. Funny enough, when we did it the first time, we had days the system was empty. There were no news, and we couldn't almost believe. But it was the truth. There was not much in the area, in the region, so they just rephrased a couple of the news. Our system, of course, recognized that, and since we said, bring me only the new ones, there was none. So we had to rephrase that rule and said, okay, bring also the ones which they rephrase, because they, if there's nothing else, then we have to show them again, of course. So that was funny to find out that. Now, what it does, it reads the feeds, then it crawls the articles, it compares all the content of the articles, and it will bring back the ones which are, you're allowed to take 5 words, and with 5 words, you have to describe me this text. Now, if this is a very focused text, you will be able to do that. You will give me 5 words which describe exactly the content. But if that text would have 3 paragraphs, and each paragraph has another content, sport, politic, I don't know, something else, and I would give you still the 5 words, maybe you can manage. If I give you only 2 words, a problem, because you have three content items and you have only 2 words to fingerprint. So of course, there must be a minimum of words which define your text, but that should be spontaneously and automatically. Now, I show you 3 samples here. The first sample, you see a big bulk of circles. Now, those circles represent the most important words. The whole pattern represents the semantic pattern of the first text. It's a very focused text. The text speaks about Kimi Räikkönen, comes back to F1, and the words in there, if we would zoom in, you would see his name and that he was racing against Schumacher and so on and so on. So very focused. So you have a very nice pattern. The second one in the middle shows you that there are 3 paragraphs, and of course there are 3 different contents. And so you have 3 different patterns. Now, if you're working with ontologies, that's what you would have to do also. You would get this page in, then you would have to try to match which ontology is working for which of the paragraphs, and then you use it and apply it there. Now here, you get that already when the article comes in. The AI1 will tell you, be careful, there are 3 different items, and it delivers you the most wanted words for all the 3 different content parts. And the last one, well, the last one has no profile at all. Why? Well, I know it because I did it. I took one sentence, another sentence from another story, another sentence from another content, so it's just bullshit. I mean, there's nothing in there. No really logic. And you can see it on the pattern. Everything is some kind connected with everything, but there is not a real profile there. And so automatically, we can find out what is the type, what is the fingerprint of the information. So that means the costs go down because you do not have any manual work in order to get the first step on your semantic road. And of course, efficiency goes up, and revenue or benefits go up, so you make more money with. So the trick is, in the first step, to get the minimum semantic out as automatically as possible. Then use all the beautiful technologies you have been showed here in the exhibition, ontologies, visualization, everything you think about. Because with the minimal, lightweight ontology, the fingerprint we get out, it's not finished. For many things, it's not enough. You have to add it on with more intelligence. But once you have a little topography out of a plain text, that's about the first step you need. And from there, you build up your application or your workflows, processes, whatever you have. So we have a little booth out there if you like to come by and